Hi everyone, my name is Farren Freddy. Today I'll be presenting my project about calculating the total height, volume, slant height, roof surface area and total tiling cost of a building that combines a cube and a square base pyramid. Before I begin, I would like to thank my lecturer Sir Afian Akbar bin Mustam for his continuous guidance and support. This project has really helped me to understand how mathematics connects to practical design and architecture. Okay, for introduction, this project applies the inactive estimation method to calculate the cost of tiling a pyramid-shaped roof. The aim is to connect the mathematical reasoning with real-life problem solving. The learning objective of this project is to calculate total height, volume, slant height, roof surface area, and total tiling cost. And now we're going to move on to problem statement. Alright, the first Polia step 1 is understanding the problem. The question shows here, look at the diagram of a cube-shaped building with a square base pyramid roof. The cube has sides of 6 meters and the pyramid has a vertical height of 4 meters, while the roof is covered with tiles costing Rm20 per square meter. By using the given information earlier, we need to determine the total height of the building, the volume of the structure, the slant height of the pyramid, the roof surface area, and lastly, the total cost of tiling. To make it easier for you, you can imagine yourself as an architect estimating the space and material cost for a new community hall. Next is the inactive representation. Polia step 2 is devising the plan. At this stage, I visualize and model the building using papers and blocks. This helps to understand how the cube and pyramid combine. I imagine separating the pyramid to calculate its measurement easily. Like you can see here, I've made a model out of block using paper and Legos with a label 6 meter and 4 meter. After that, I also devised a plan by preparing the formulas to be used, which is the formula of slant height of pyramid, the volume of cube, volume of pyramid, surface area of roof, and lastly, the formula of cost. Next, we're going to move on to the step 3 of the Polia method, which is carrying out the plan. Alright, next, let's find the slant height of the pyramid. The slant height can be found using the Pythagoras theorem because the pyramid forms a right triangle between the vertical height and half of the base and the slant edge. And there I have put the image, the example. And for the formula, it is this, where A is the base length, which is 6 meter, and H is the vertical height of the pyramid, which is 4 meter. Now, we just substitute in the base length and the vertical height of the pyramid, and you'll get the answer, which is the slant height is 5 meters. Now, the roof surface area is the total area of the 4 triangular faces of the pyramid. For the formula, it is area equal to 1/2 times perimeter of base times slant height. The perimeter of the square base is P equal to 4 times 6, which is 24 meter. Now, by using the 24 meter, we just substitute in the number into the formula of area, which is area equal to 1/2 times 24 meter. 24 meter is the perimeter of the square base that we have counted just now. Okay, now we're going to times it 5, which is the slant height that we found earlier. Now, the total roof surface area is 60 square meters. Alright, now we're gonna move on to the tiling cost. To calculate the total cost of the roof, we just need one simple formula, which is total cost equal to roof area times cost per meter square. Now, we just substitute in the roof area and the cost per meter square, which is 60 times 20 equal to 1,200 ringgit. Therefore, the total cost for the roof tiles is Rm 1,200 ringgit. Now we're gonna move on to total height and total volume. But first, let's look at the height. The bottom part is a cube with a height of 6 meter, and the top part is the pyramid and has a vertical height of 4 meter. So, the total height is just those two added together. 6 meter plus 4 meter equal to 10 meter. Simple, right? Now, to calculate the total volume, it's just easy. Since it's just two separate shapes, we have to calculate the volume of cube and the volume of the pyramid and then add them up. The formula is shown here, which is total volume equal to volume of cube plus volume of pyramid. Okay, for the volume of cube, the formula is just side times side times side, or simple A cube. Since the cube height is 6 and its side length is also 6, so the side equal to 6 cube. For the pyramid volume, formula is 1/3 times base area times height, or more simple, 1/3 times base square times height. The base of the pyramid is the same as the top of the cube, which is 6 meter, while the vertical height is also the same, which is 4 meter. To get the final answer, we just add those two volumes together after you calculate them in those formula. The total volume of that whole combined shape is 264 cubic meters. Simple, right? Now, following Polya step 4, look back. I reflected on the problem solving process. I realized that breaking the building into two parts, the cube and the pyramid, made the calculation much easier and more organized. This step helped me to avoid confusion and ensured I applied the formulas correctly. Using the inactive representation, like visualizing the shape with paper or blocks, allowed me to see how the pyramid fits on the cube and how each measurement contributes to the total roof area and volume. Looking back, I understand that careful planning, visualizing, and executing the steps systematically not only improves accuracy but also strengthens my confidence in solving real-world mathematical problems. In conclusion, through the inactive method, I learned that mathematical understanding can begin through real, hands-on experiences. By visualizing and estimating measurements using physical models or mental images, I was able to connect real-life building concepts with mathematical reasoning. Thanks again to Mr. Afian Akbar bin Mustam for guidance and my classmate for encouragement. That is all from me. Thank you for watching my presentation.